So, abbreviated history of earthquakes in the Northwest from Rachel.
Sorry, I left my water bottle up here. Okay, so I think it's important that you know a little bit of the science that's behind the map so that you know why we're putting all this effort into it, so that you believe what's on the maps. And we'll also give you a chance to ask some questions at the end. So I am going to go a little bit over the science. So what we have is a 10,000-year geologic record of these large earthquakes happening off the Oregon coast. And the image on the left here shows all of these locations where some core samples have been taken. And this shows kind of the Oregon coast is up here, and this is the shelf actually slopes down, and then it reaches the abyssal plain out here. And so what happens is during an earthquake, all this shaking happens, and some sediments fall down these little canyons, kind of like river canyons that we have above ground. This is underwater, and they roll down onto this abyssal plain, this flat area, and this is where we've taken these soil samples. So this is an example of what one looks like when the scientists come in. They go out in the boat, take the sample, come back, and this is what it looks like. And what they do is those sediments that have rolled down those canyons and landed in the bottom of the ocean, they're called turbidites. And that's a scientific name for sediments. And what they do is they find these turbidites in here, and they measure them, they date them, send them off, process them in the lab. They also do correlations. They can see different types of sediments, and so they make all these correlation tables. But it's all of this science that is rolled into the next graph that I'm going to show you, which is that there have been 19 Cascadia subduction zone earthquakes in the last 10,000 years. There are 19 events that they have been able to find in these core samples all the way up and down from California, Northern California, all the way up to British Columbia. These little bars represent sediments that they have measured and they have correlated in all of those samples. So there's been a lot of geologists working on this, and what this table shows you, this is time across the bottom. This is year 2000, right at the end, we're at 2013. This is all the way minus 8,000 AD. And these bars are events that have happened, and what these different heights are, that they're measuring the size of those turbidites. So you can see along this bar, there's a bunch of events that have smaller turbidites, and then there's a couple that have really large, pretty large turbidite masses. And the last one that has occurred is 1700 AD. So a lot of times you'll hear that people will say, well, when did the last event happen? It was about 300 years ago. And that's why you hear all the scientists saying, oh, we're now kind of due, because usually the minimum time between them has been a couple hundred years, and we know that it's been a few hundred years since the last one occurred. So we created this team of scientists, and everybody up here that's shown is a specialist in some area. One of them is a specialist in those sediments that are offshore. One of them are a specialist in earthquake and fault mechanics, and et cetera, et cetera. You probably heard some of the names, like Chris Goldfinger. He's put out a bunch of reports. He's down at OSU. And so we put together this science team together, and they created a computer model, essentially, is what they did. And this very sophisticated model, they spent a couple of years on tweaking it. Cannon Beach was actually used as a pilot. We used Cannon Beach as one of our pilot study areas. And they created a ton of tsunami scenarios. And the whole goal of this program was to create data for the entire Oregon coast. So we said, well, we can't run 50 tsunami scenarios, for the whole coast. So we're going to narrow it down, and we've narrowed it down to 5 local tsunamis and 2 distant tsunamis. So we've been talking a lot about local and distant, so I think you know what they are now. And can you go back? And so the key thing that we haven't talked about is the 2 distant scenarios, and they are from Alaska. So a lot of people say, well, we had a Japan event a couple years ago, why did you pick Alaska? Well, Alaska is actually the closest location to us that will generate a distant tsunami. So it takes a wave about 4 hours to get here from Alaska. So it's still a distant tsunami. You can still sit in your house and drink coffee, as Peter says, if you're not in a distant evacuation zone. But we did 2 distant scenarios. One is an AK-64, and that one is a replica from 1964. Was anybody living here in 1964? And you remember the really big Alaska earthquake that happened? And so that model was to replicate that inundation that occurred on the Oregon coast. We have a lot of record of what happened in 1964. So that's what that model is. And then the AK Max, this is a hypothetical, if all the stars align, and we moved the location of the Alaska source of that earthquake compared to 1964. We moved it over a little bit and gave it a direct shot to Oregon. So much like Peter pointed out that wave that went straight across the Crescent City in that image earlier, that's what this model is doing. It's a really big earthquake, and we just line it up so that it was worst case possible scenario. So that's what Alaska maximum is. So those are 2 distant tsunamis. So that chart that I showed you a minute ago is this is it, same thing, except for now it's color coded. And now you can see that we've color coded these smaller ones. They're kind of small and medium ones. And the reason we colored them in purple and set them apart from the yellow is because they happen more frequently. If you look at this chart, you can see there's a lot more small and medium events that have happened in the geologic history. However, we can't ignore the big ones. So there's a few big ones, including this one really big one that falls in a really large event. And so we're going to talk a little bit more about the maps, but these colors will make sense to you in a minute. So this is what we get to work with. So I'm here so you can thank me to save you and your eyes from having to stare at this, because this is what the model output looks like. Next slide. They don't want to stare at this very long. So we take that model data and we turn it into maps, because we think people read maps and can understand maps a lot easier. So we took that model data. We have 2 types of maps. We have inundation maps, which show the 5 local, we call them tsunami t-shirt sizes: small, medium, large, and extra, extra large. And then we also have maps that show the 2 Alaska scenarios. And the chiefs over there are standing next to these inundation maps that they were just released this week. They're very science heavy, and I'll talk a little bit more about those in a minute, but afterwards you're welcome to go and look at those. And so what we do is we take the worst case local, which is the XXL, a really, really big event, and we take the worst case distant, that Alaska maximum where all the stars align in Alaska, and we put those on the evacuation brochures. So that evacuation brochure that's at the back of the table that you looked at, there's 3 colors on it: a green, a yellow, and an orange. Go ahead. So this image should look familiar. The orange matches the AK Max. The yellow matches the XXL, which are shown on those different maps over there. So those maps over there are called the Tsunami Inundation Maps. We call them TIMS for short. There's actually 10 of them to cover the entire Oregon coast, or Clatsop coast. There's about 100 of them covering the whole Oregon coast. And this is images of what the Seaside Gearhart maps look like. And then, of course, we have the evacuation brochures, and there are 7 maps for Clatsop County, and there's all of them are at the back table. And so I would encourage you, if you travel frequently to down to Cannon Beach for something, or you have family members or a church or wherever, pick up the maps that you need for wherever you go on a regular basis. So I think I'm going to cover a little bit more on the TIMS too. So this is Clatsop County, and this is showing you the layout of all of the TIM maps. We only brought a few of them. We brought the one from the Clatsop Spit, and Warrenton North, Warrenton South, Rylea, and we bought the Delray Beach, Sunset Beach, Delray Beach map. So The rest of them are available. You can order them online if you'd like. And we'll talk about where it is a little bit later. So the reason you guys got the evacuation brochures is because those maps over there actually have a lot of science on them. They were meant for emergency responders, like the guys over there. They were meant for local planners, people who are really interested in science. So if you're a science geek like me, you will probably like them, or if you really like maps. They're loaded with charts like this. And so it's important, though, that even if you don't want the map, we want to talk about this, because this is showing wave arrival and the height at the mouth of the Skipanon River. So you know the waves have to come around the Flats of Spit and go a little bit up the Columbia River in order to reach downtown Warrenton. So we modeled, as part of the model, we set up a bunch of what we call gauge stations. These are simulated tide gauge stations. Tide gauge stations. I'm having a tongue twister. And so this number 18, you'll see, is actually on that map over there. And it is located right at the mouth of the river. And so in the model, this simulated spot, we said, tell us what the wave heights are going to be, and tell us when these waves are going to arrive. So what this chart is showing is time. This is across the bottom in hours. So the earthquake happens at 0, and 8 hours later, you can see there's still waves coming in at the mouth of the river. The key to note here, this is the maximum XXL at the very top, and it's just shy of 30 feet. So it's a 30 feet wave, roughly. It's 29 point something in our model. So the good news here is it took 37 minutes for that whole big wave to get there. So you probably saw in the paper the other day that Astoria has 40 minutes before the wave comes. Warrenton is kind of pretty similar. You have 40 minutes. But that's 40 minutes until the height of to the top of the wave, the full height of the wave reaches you. So right here at about 10 feet I marked, this is 20 minutes. So my point here is in 17 minutes, this wave went from roughly 10 feet to 30 feet. So that tells you how fast the wave comes in. So do you have a little bit of time versus being on the beach? Because I'm going to show you the beach one in just a second. You'll be glad you live in Warrenton. But you do have a little bit of time. But the point is that, if you can just get started toward your evacuation area. Warrenton was lucky compared to some areas. There are places that are high ground. There are some communities that, you probably read in the paper, Earhart didn't even have anywhere to send their people. So there are high ground places. There are places, if you start walking, you can beat this high wave, and this high wave is only 30 feet. Let's go to the next slide. I say only because you'll be glad in just a second. So this is the Alaska. Same exact tide gauge station at the mouth of the Skipanon River. It starts right here, 4 hours. Nothing before 4 hours. So that shows you have at least 4 hours before this wave from Alaska. From Japan, it was 8 to 9 hours before those waves ever reached us. So you have plenty of time to get a report from the local officials telling you, yes, if you're in the distant zone, you should evacuate. You have time. Don't panic. And this shows you, and this wave, it's so little compared to that last one. There is some inundation. And so that's, again, we brought the plate that shows the distant tsunami. Warrenton is kind of flat and low, so there definitely is inundation from a local or a distant event. But my message here is you have time to prepare for a distant event. You have time to know if you're in the distant evacuation zone or not. You have time to make it to your friend's house, go pick up your kids or whatever you need to do. Don't panic, don't run to Portland. If it's a local event, it's a completely different situation. So this is a wave, the same wave height type of chart. The difference is this is the location of that gauge. This is Camp Raleigh. And then we put this gauge right off the beach. It's right on the beach, and you can see it on that map over there. Much different situation. If you were on the beach and this happens, get out. And I mean get out fast. Because this is 18 minutes in, and so you have a 20-foot wave. And by 30 minutes, It's at 75 feet, something like that. So it's right on the beach. It's a completely different scenario. That wave is coming directly on shore versus Warrenton. If you're in downtown Warrenton, you're working and you're sitting, you have a little bit more time, to grab your bag. If you're on the beach, you need to be heading toward high ground immediately because it's a really big wave and it's really fast. And so that's why we tell people you have 15 to 20 minutes, because if you are on the beach, it's reality. You really do only have 15 minutes to try to make it to high ground. So this is an animation that came with the model, and these are really cool to look at, but once we mash play, some of the text of where you're at will disappear. So find out where you're at. So this is I forgot I have a laser. So this little box right here is this is the zoom in of this little box. So if you're visiting from Tillamook, you may want to keep your eye on this area down here. This is where Tillamook is, Columbia River, up in British Columbia. So this is Warrenton, Astoria over here. So everybody got the spot you want to look at, and Peter will mash play. So this is waves coming in. This is the big view, and you'll see it entering the beach here in a minute. These are waves coming in. These are the big waves coming in. And what you can see is them coming in, and then they also come up from Highway 101. And you'll probably notice it took a minute for that wave to come in here from the Columbia River. And these little graphs over here just show time. So we're at like an hour and a half into it. We ran these models for about 8 hours, but after 8 hours we kind of ran out of money. We can't run these things. The waves continue for hours and hours, but we have data for generally about 8 hours for everywhere. I'm going to start it over one more time so people can see. It's kind of really cool to watch. You pick your spot where you want to. So we're at 30 minutes right now. So I'm looking at the time. We're coming up on an hour. It's going to be at an hour. So you can see the waves are still moving, still refracting. Once they get in the Columbia River estuary, they'll keep bouncing around the shores. If you live in an estuary area, if you live up in here, those waves will continue bouncing around up in here, and also in the Pacific Ocean.